In a world where innovation meets engineering marvels, imagine a plane with gigantic wings soaring high above the clouds, collecting top-secret intel for the military. That's the U-2, with wings stretching to the horizon and a sleek design that defies convention. The U-2 stands as a testament to human ingenuity and pioneering spirit. So let's delve into the exhilarating journey through the skies aboard the legendary marvel of aviation with wings that stretch wider than your wildest dreams. The Lockheed U-2, nicknamed Dragon Lady, is an American single-engine high-altitude reconnaissance aircraft operated from the 1950s by the United States Air Force and the Central Intelligence Agency. 70,000 feet all-weather intelligence gathering. During the early 1950s, the best intelligence the American government had on facilities deep inside the Soviet Union were World War II German Luftwaffe photographs taken during the war of territory west of the Ural Mountains, so overflights to take aerial photographs of the Soviet Union would be necessary. The committee suggested a plane with advanced optics flying above 70,000 feet. Officials at Lockheed Aircraft Corporation heard about the project and decided to submit an unsolicited proposal. To save weight and increase altitude, Lockheed executive John Carter suggested that the design eliminate landing gear and not attempt to meet combat load factors for the airframe. The initial designs for what would become the U-2 were created by Lockheed engineering guru Clarence Johnson in 1953. Working under the cloak of secrecy in the famed Skunk Works division, Johnson envisioned a light, high-altitude reconnaissance aircraft capable of flying above the reach of Soviet anti-aircraft fire. The U-2 borrowed its sleek looks from the profile of a traditional sailplane. Its long, tapered wing, one-third the weight of what was normal at the time, allowed it to fly missions covering a range of 3,000 miles and carry up to 700 pounds of the latest photo reconnaissance equipment to a staggering and unprecedented altitude of 70,000 feet. Unfortunately, by the time Johnson could provide a full proposal to U.S. officials in the summer of 1954, President Eisenhower and CIA Director Allen Dulles had already signed off on two competing designs for a high-altitude reconnaissance aircraft. Johnson was undeterred. He knew he had the better plane, so he offered up a deal that no general could refuse. Not only would he assume complete responsibility for any maintenance and service, an entirely new concept in aviation, but he would also have a U-2 in the air in just 8 months. Incredibly, Johnson almost met his own impossible deadline, delivering the first U-2 for a test flight on July 29, 1955, 9 months after signing the contract. President Eisenhower now had his secret weapon, and he was determined to use it to prevent the Cold War from turning red hot. By early 1956, Soviet Premier Nikita Khrushchev had declared that his country was making missiles like sausages and that he would soon have a hydrogen bomb capable of striking any point in the world. Any uninvited guests flying over Russia, he also warned, would be shot down with impunity. Beginning in the summer of 1956, Lockheed's U-2 would prove him wrong. On July 4th, Hervé Stockmann flew a U-2 from Wiesbaden, West Germany, deep into the heart of the Soviet Union, capturing detailed photos of airfields, factories, and shipyards previously unattainable by other aircraft. The plane was tracked by Soviet radar, but Stockmann's U-2 flew beyond the reach of Soviet interceptors and anti-aircraft fire, returning home with history-altering intelligence. U-2 flights revealed that the Soviets were more concerned with building tractors than tanks. Russia's ability to produce high-end bombers was unimpressive at best. Its missiles, while numerous, were better suited for intermediate attacks against Europe than a long-range attack on the United States, with most being unready to fire at all. Thanks to the U-2, Eisenhower had the information he needed to avert a massive arms buildup and a potential war. It was only a matter of time before advancing Russian anti-aircraft technology caught up with the spy plane. On May 1st, 1960, a Soviet surface-to-air missile struck near a U-2 piloted by Francis Gary Powers while on a reconnaissance mission over Russia. Powers was sentenced to 10 years in a Soviet labor camp on August 17, 1960, but would be released 2 years later in exchange for spy Rudolf Abel. The U-2, however, would continue to be a critical asset for U.S. intelligence agencies, especially during the Cuban Missile Crisis. It was a U-2 manned by Major Richard Heiser that captured photos of Soviet missile installations in western Cuba on October 14, 1962, revealing the Russians were capable of launching a nuclear strike against the U.S. Over the course of the next 13 days, U-2 flights would keep President Kennedy abreast of Soviet activity in Cuba, buying the administration enough time to broker a deal with the Soviets. Russia would dismantle its weapons in Cuba in exchange for a pledge by the United States not to invade the island, pulling both sides from the brink of nuclear war. Initially projected to have an operational life of just 2 years, the U-2 would go on to see service in every subsequent American war while showing remarkable versatility as a non-military aircraft. When equipped with a wide variety of sensors, the U-2 has morphed into everything from a high-tech NASA platform for conducting physics experiments to a high-altitude tool for tracking the migration of destructive spruce bark beetles through the forests of Alaska. The U-2S is a single-seat, single-engine, high-altitude, near-space reconnaissance and surveillance aircraft providing signals, imagery, and electronic measurements and signature intelligence, or MASSINT. Long and narrow wings give the U-2 glider-like characteristics and allow it to quickly lift heavy sensor payloads to unmatched altitudes, keeping them there for extended periods of time. The U-2 is capable of gathering a variety of imagery, including multispectral electro-optic, infrared, and synthetic aperture radar products, which can be stored or sent to ground exploitation centers. In addition, it also supports high-resolution, broad-area synoptic coverage provided by the optical bar camera producing traditional film products, which are developed and analyzed after landing. The U-2 also carries a signals intelligence payload. All intelligence products except for wet film can be transmitted in near real time anywhere in the world via air-to-ground or air-to-satellite data links, rapidly providing critical information to combatant commanders. MASSINT provides indications of recent activity in areas of interest and reveals efforts to conceal the placement or true nature of man-made objects. Routinely flown at altitudes over 70,000 feet, the U-2 pilot must wear a full pressure suit similar to those worn by astronauts. A second U-2 pilot normally chases each landing in a high-performance vehicle, assisting the pilot by providing radio inputs for altitude and runway alignment. These characteristics combine to earn the U-2 a widely accepted title as the most difficult aircraft in the world to fly. The U-2 is powered by a lightweight, fuel-efficient General Electric F-118-101 engine, which negates the need for air refueling on long-duration missions. The U-2S Block 10 electrical system upgrade replaced legacy wiring with advanced fiber optic technology and lowered the overall electronic noise signature to provide a quieter platform for the newest generation of sensors. So let me know your ideas of this giant winged plane in the comments below, and if you enjoyed this video, make sure to give it a thumbs up and subscribe for more fascinating content coming your way. Until next time, stay curious and keep exploring the world around you. See ya! Bye!